In this video, we'll be looking at the concept of enlargement. Now, for us to really grasp this concept, let's look at what this website has to say. And this website is wtmaths.com. This is the source that this information came from. Okay, so the enlargement. Now, an enlargement is the only transformation that can change the size of an object or shape. Now, two types of information that are required for enlargement. We're told these are the center of enlargement, and the second one is the scale factor. Now, what we want to do is to locate the center of enlargement. So in this illustration here, we can clearly see that we have a center of enlargement right here. Let's call the center of enlargement center C. Sometimes it's given as O and perhaps other letters. Now, what we need to do is to draw ray lines. Okay, a ray is simply a line that would start here, for instance, and go on, but has an arrow head. Okay, so we draw ray lines from the center of enlargement through the vertices of the shape. So we're going to draw a straight line through the vertices. Now this is the first vertex of, or this is one of the vertices of this original triangle. This is another vertex, and this is another vertex. So let's label them. Let's say we call this vertex P. Let's call this one vertex Q, and let's call this vertex R. So these are the vertices. A vertex is simply where two straight lines meet at a point. This point here is called a vertex. And of course, once you have a vertex, you have an angle. But we're focusing on the vertices for now. Okay, so we draw a straight line from the center of enlargement through each vertex. As you can see, these red lines going through the three vertices of triangle PQR. Now we extend it all the way through. Now we also have the enlarged triangle. So this is the original and this is the image, right? The enlarged triangle is the image of the original we call the object. So from the object to the image, from the original to the enlarged shape. Now, if you look at the sides PQ, that's the original length. The enlarged length, therefore, let's call this P prime, Q prime, and call this other vertex R prime. Now, P prime is the image vertex of the object vertex P. Q prime is the image vertex of the object vertex Q. And R prime, which is here, is the image vertex of the object vertex R. So if PQ is X and the scale factor is 2, then the distance from P prime to Q prime is 2x because the scale factor is 2. That means this length, PQ, has been enlarged by twice the amount. So for instance, if this is 10 centimeters, then this is be 2 times 10 centimeters, with 20 centimeters. If this length here is 15, then this will be twice that amount, which would be 30, 2 times 15. So as we can see in this illustration that, for instance, PQ, let me just look at it, P prime to Q prime is actually equal to 2 times the length of PQ. Some correction there. So the image length is produced by the scale factor multiplied by the corresponding object length. So you just take the object length, the length of the object, for instance PQ, you multiply by the scale factor. So this, in case this is X, we multiply by a scale factor of 2, and that gives us the image length, which is 2x. And this is a nice formula to work with. So if we were to look at from P prime to R prime, P prime to R prime, then it's equal to twice the length of PQ. R. Okay, so hopefully you understand that. But there are other ways of finding that apart from looking at the length of the object and the image. We can also look at from the center of enlargement to a vertex, an object vertex. So for instance, from the center of enlargement C to the object vertex Q, we have a distance. In this case, we're given as D, is given as D. But we notice that from the same center of enlargement C to the corresponding vertex Q prime belonging to the image is actually equal to twice or 2 times D. With this 2 here is the scale factor multiplied by the original length, that of CQ. So we can see it's twice the length of CQ. Right? So from C to Q prime, the image length is equal to 2 times the center of enlargement to the object length Q. So even with this formula here, we can see this is very similar to what we have over here, right? Okay, so now that we get that, it says if a shape is being enlarged by a scale factor of 2, the distance from the center of enlargement to each vertex will be twice the size. From the center of enlargement to each vertex of the image will be twice the amount from the center of enlargement to the object vertex. The size of the shape will also be twice the size. In other words, the length of any of the sides will be twice the amount. Enlargement will preserve the angles of the shape as well. So whatever angle this is, for instance, angle PQR is actually equal to angle P prime, Q prime, R prime. So the only thing that didn't or would not enlarge in an enlargement are the corresponding angles. The corresponding angles will be the same. So for instance, if this is 90 degrees, then this angle here will also be 90 degrees. Whatever angle this is, this angle will also be the same. So let's look at the problem we're given now. It says here, triangle A prime, B prime, C prime, right? It's this triangle here. Obviously, the image triangle is an enlargement of the object triangle ABC with a scale factor of 3 from the center O. Find the value of y. Notice that we're not given the lengths of any of the sides of the object or image. So what we need to do though is to look at the fact that we have from the center of enlargement to corresponding vertices, in this case A and A prime for the object and image respectively, that from the center of enlargement to the image vertex, its scale factor is equal to the scale factor times the distance of the center of enlargement to the object, corresponding object distance. So from the center of enlargement to the image vertex, let's write that. Center of enlargement in this case is O, to the image vertex A prime, it's equal to the scale factor, we're told the scale factor is 3, multiplied by the same center of enlargement O to the corresponding object vertex. Now how can we compute or get the measurements from O to A prime? Now from O to all the way down to A prime is a combination of what? Let's go O to A prime is distance O to A, first off, plus from A to A prime. You can clearly see that. From O to A is actually y minus 2 added to A to A prime. So this distance from here to here is the distance y plus 3. We can add the y's, y plus y, because this is actually a positive y plus positive y. That's going to give us 2y. And then we have negative 2 plus 3. And negative 2 plus 3 is actually 1. So that's positive 1. Some person may say to group like terms, so we have y plus y, negative 2 plus 3. Simplified as this. So that's the distance from O to A prime. It's actually 2y plus 1. We multiply 3 by the distance O to A. Now from O to A, we have distance y minus 2. So we multiply by that entire distance of y minus 2, so we must use bracket to show that we are multiplying the scale factor by the total distance of OA, which is y minus 2. So we have 2y plus 1 equals, now 3 times this amount will be what? If we have 3 times y minus 2, we use distributive law. So it's going to be 3 times 2, which give 3 times y, sorry, give us 3y. And then 3 times negative 2, which gives us negative 6. Now we need to group like terms. So we're going to have 2y, transposing the y term over. We have minus 3y. Put the equal sign. Then transpose this plus 1 over. Already have the negative 6 there, but we're transposing the plus 1 as a minus 1. So technically what we did was to subtract 3y from both sides, leaving us with 2y minus 3y on this side, and then subtract 1 from both sides, leaving us with negative 6 minus 1 on this side. And simplifying this further, we get negative 1y equals negative 7. Of course, we have a negative 1 multiplying y, so to get rid of it, we divide. This will give us positive y equals positive 7. Now, what some person might have done from this stage here is to instead of transposing the bigger quantity of y, they would have transposed the 2y over. So this 2y goes over the equal sign as negative 2y. And the positive one, that's already there, we'll leave it here on this side. And the negative 6 goes over to this side as positive 6. And so we have 7 is equal to 3y minus 2y is y, so y equals 7. Another option. Okay, so we can clearly see that the answer is actually y equals 7. So therefore, from O to A is actually 7 minus 2. So this distance here from O to A is actually equal to 5 units. And this distance from A to A prime is equal to y plus 3, which means y is 7, so 7 plus 3, which is 10. Now, you might wonder why, how could this be 5 and this be 10 if scale factor is 3? Remember, it's from O to A prime. It's from the center for enlargement to A prime. That is 3 times the distance of the same center of enlargement to the corresponding object vertex of A. Okay, so remember we have that from O to A prime. From O to A prime is actually 5 units plus 10 units, so that's 15 units. That's distance. And it's 3 times OA, which is from O to A, is 5 units. We can see it makes sense. So 15 units is equal to 3 times 5 units, which is equal to 15. 15 equal 15. So we can see that this formula is correct. But the answer is y equals 7.